Hello, calculus students of mine. In this video, I'm going to help you with your Calculusthenics number 2, and what I'm going to do is help you with numbers 1a, 2a, 3a, and 4a, and then you'll have examples to help you with 1b, 2b, 3b, and 4b. So let's go ahead and get started on number 1. So as you look at number 1, the first thing I want you to notice is that we're taking the limit as x approaches 0. So this is not a problem where we're going to compare degrees on the top and the bottom. We're just going to see what happens to this ratio as x gets closer to 0. So if we tried direct substitution, you'll notice that the numerator would 0 out and the denominator would 0 out. So we'd get that indeterminate form of 0 over 0. So direct substitution is not going to work. So the next thing we might want to try is factoring. Now if you look at the three terms on the top, you'll notice that the three terms on the top have a common factor of x squared, and the same thing is true of the bottom. The three terms on the bottom have a common factor of x squared. So let's try factoring that out. All right, so I'm going to rewrite the limit as x approaches 0 of, now if I'm going to factor an x squared out of the numerator, what that means is I'm going to divide each term in the numerator by x squared. So 3x to the fourth divided by x squared would give me 3x squared. And then negative 4x cubed divided by x squared would give me negative 4x. And then plus, when I take x squared and divide it by x squared, I get 1. All right, and then let's do that same thing on the denominator. Let's factor out an x squared. So x to the fourth divided by x squared is x squared. And then minus 6x cubed divided by x squared is 6x. And then 3x squared divided by x squared is 3. All right, so now you'll notice that we have the common factor of x squared that'll divide out. So let's go ahead and cancel that. Okay, and then if we use direct substitution at this point on the numerator, 3 times 0 squared is 0. So we'd have 0 minus 4 times 0 is 0 plus 1 on top. And then the denominator we'd have, when we put zeros in for x's, we'd have 0 minus 0 plus 3. So now we can see that this limit is 1/3. So now let's take a look at number 2a. And again, if we try direct substitution, if I tried to put, whoops, what did I just do? Sorry about that. If I tried to put negative 6 in for x in this denominator, let's see what would happen. Let's see, negative 6 squared is 36. We'd have 36 and then minus 24 minus 12. So you'll notice that that denominator would 0 out. So direct substitution is not going to work. So we might want to try factoring. So if we factor, we would have the limit as x approaches negative 6 of, we'd have the x plus 1 on top, and then that denominator is going to factor into x plus 6, x minus 2. Well, I was hoping to find a common factor that would cancel, but as you can see, there is no factor that's common. So we can't cancel anything. What we need to notice is that as x approaches negative 6, when x is equal to negative 6, we'd have a 0 in the denominator. So what that means is we have a vertical asymptote when x is equal to negative 6. So that means we need to do a little analysis here because we need to decide what is the limit doing on both sides of negative 6. Is it approaching positive infinity from the left and positive infinity from the right? Could it be approaching negative infinity from both sides? Or could it be a situation where the limit on the left is approaching one of the infinities and the limit from the right is approaching the other? So the way we can analyze that is just to make a little chart. So let's choose values that are on either side of negative 6. So let's choose negative 7 for x, and then we'll choose negative 5. And let's just make a little chart, and what we're going to do is we're going to evaluate this function at negative 7 and negative 5. So we're going to evaluate the x plus 1 over x plus 6 times x minus 2. Now, I'm not really interested in what these actual function values are. What we're interested in is what the sign is. So we may not find the exact value, but let's see what would happen when x is equal to negative 7. So we'd have negative 7 plus 1 on top, and then on the bottom we'd have negative 7 plus 6 times negative 7 minus 2. So let's think about what kind of numbers we'd get. We'd have a negative number on the top, and then on the bottom, negative 7 plus 6 is negative 1. That's negative. And negative 7 minus 2 more is negative 9. So that's a negative number. So what are we going to have? We're going to have a negative on top, and then on the bottom, a negative times a negative is a positive. So all that to say that when x is equal to negative 7, on the left side of our target value of negative 6, this function is going in the negative direction. So now let's see what's happening on the other side. So I'm going to plug in negative 5. So when I plug in negative 5 in, I'd have negative 5 plus 1 on top, and then in the denominator we'd have negative 5 plus 6 times negative 5 minus 2 more. So what kind of numbers are we going to get? A negative number on the top, and on the bottom I'd have a positive number times a negative number, because negative 5 plus 6 is positive, and negative 5 minus 2 more is negative. So that gives me a negative over a negative, which is positive. So what that tells us is, as x approaches negative 6 from the left, okay, from the left, this graph is going in the negative direction. When x is approaching negative 5 from the right, or excuse me, approaching negative 6 from the right, the graph is going in the positive direction. So what that tells us is this function is behaving differently on the left side of the vertical asymptote than it is on the right side. So since we have different left and right behavior, then we would say that this function, this limit, the limit of this function as x approaches negative 6 does not exist. So now let's take a look at number 3a, and you'll notice that this time our target value for x is x approaching a limit. So we're taking the limit of x plus 1 over x squared minus 1 as x approaches the limit as x approaches 0 of sine x over x. So I just threw this in there because I wanted you to one more time review this special limit, the limit of sine x over x as x approaches 0, and hopefully you remember that that limit is equal to 1. So we could rewrite this problem like this. We could say the limit, we could say the limit as x approaches 1 of x plus 1 over x squared minus 1. All right, you'll notice if we tried to use direct substitution, we'd have a 0 in the denominator, so direct substitution isn't going to work. So let's see what factoring will do for us. Let's go ahead and factor that denominator. So we'll take the limit as x approaches 1 of x plus 1 in the numerator over x plus 1 minus x times x minus 1. Okay, so now you'll see that we have a common factor of x plus 1. So this simplifies to the limit as x approaches 1 of 1 over x minus 1. Okay, so now you might already know what this graph looks like. It is just a transformation of the parent function 1 over x. But if you're not familiar with the graph, again, we can do a little bit of analysis. We know that there's a vertical asymptote at x equals 1. By the way, I just want to remind you that up here, since x plus 1 factored completely, that's another point of discontinuity where x is equal to negative 1. And since we had a common factor that factored completely, that's where this graph has a hole. But that's not what we're interested in. We're not interested in what this graph is doing as x approaches negative 1. We're interested in what this graph is doing as x approaches positive 1. So let's do a little analysis. Let's make a chart, and let's see let's choose x values on either side of 1. So how about we choose 0. because 0 is to the left of positive 1. And then let's also choose 2 because 2 is to the right of positive 1. So then let's see what happens to x plus 1 over x squared minus 1 when we put 0 in for x and then when we put 2 in for x. Well, when we put 0 in for x, let's see, we would have 1 over 0 squared minus 1 is negative 1, so that gives us a negative 1. Okay, when we put a 2 in for x, then we'd have 2 plus 1 is 3 in the numerator, and 2 squared is 4 minus 1 is 3 in the denominator. Okay, so we can see that this function is behaving differently on opposite sides of positive 1. When x approaches positive 1 from the left, we're going to get negative values, but when x is approaching positive 1 from the right, we're going to get positive values. So we have a function where as x approaches our target value of positive 1, the graph has different behavior to the left than it does to the right. So in that case, we would say that this limit does not exist. And finally, let's take a look at number 4a. The good news on this problem is that when we try direct substitution, when we go ahead and put a 3 in for x, direct substitution is going to work, but we do need to remember some trigonometry. So let's go ahead and do our direct substitution. So I can just go ahead and say that this is equal to tangent of, I'm going to replace that x with 3, so I'd have 3 pi over 4 in the numerator, and then that's all over 3 in the denominator. So now we just need to remember what tangent of 3 pi over 4 is. So let me just quick draw a unit circle. Okay, 3 pi over 4 is going to be over here, where our reference angle would be pi fourths. Tangent of pi fourths, I hope you remember that at that point the x and the y values are the same. They're both square root of 2 over 2, and tangent is sine over cosine. So that means that the tangent of pi fourths is 1, but now we need to decide, is it a positive 1 or a negative 1? So perhaps in the past you've learned the little trick to help you remember what the signs of your trig functions are in each quadrant. So if you put an A, S, T, C, which the mnemonic device for that is all students take calculus. Over here in quadrant 2 where we are, where our angle is equal to 3 pi over 4, the S stands for sine, which means sine is the only trig function that has positive values in quadrant 2. Everything else is negative. So what that tells us is tangent of 3 pi over 4 is negative 1, and that's all over 3, so our final answer is negative 1/3. Okay, so I hope this video has been helpful. Now if you go and try 1b, 2b, 3b, and 4b, you'll see problems very similar to the ones that we just did. And if you still have questions, be sure and ask me at school, and I'll be glad to help you.